Hello everyone and Adab. I am here on behalf of the Burak Planetary Society with the cadets and the commanders of the 18th Burak Space Camp for a very special session today. Burak Camp started in 1993 as an initiative of Dr. Shahid Mahmood, who saw the model of the Uzbek space camps and since brought it to Pakistan to have different activities and lectures that introduce students from some of the brightest students from all across Pakistan to lectures on science, entrepreneurship, and much more. Today we have with us a very distinguished speaker who is at the forefront of promoting scientific and rational thought within Pakistan. He has taught at some of the most prestigious universities in the world, including MIT, and is a personal inspiration of mine as well. Please join me in welcoming to the stage Dr. Pervez Hoodbhoy. As always, you are requested to switch your cell phones off to silent and not create any kind of disturbance during the lecture. Thank you.
Thanks very much. Great to see all of you, and sorry there's not enough space in this auditorium for everybody, but and I hope the people sitting over here will be able to see. So today I am going to talk about some of the biggest questions that are around. And these are questions that have challenged the human mind and the human imagination for tens of centuries. And some of the biggest minds have thought about these questions. So I will, of course, be able to make tentative guesses towards this and tell you about the state of knowledge such as exists today. Of course, knowledge keeps improving and changing, and that's what we are so happy about in science. Let's get people settled a little bit. कुछ लोग अगर ज़मीन पर अगर उधर बैठ जाएं तो अच्छा होगा. इधर जो लोग हैं उनको कुछ नहीं नज़र आएगा. Because why don't you sit down over there? Maybe that'll be better. Acha. Well, sorry, this auditorium has limited size. The questions that have challenged the human imagination, among them is, what is the world made of? And, well, of course it's material, but the earth is material, and the earth is there before us. Something is holding up the earth. What is it? Where did we come from? Why are we here? The existential question of all times. And could there be life elsewhere in the universe? So these are the questions that we shall be considering. Well, people have thought about these seriously for thousands of years. And about 2,500 years ago, you had some of the greatest minds of history. People like Plato and Aristotle, Democritus, Socrates, and they thought about the world and all these big questions. Of course, today we know a lot more than they do because the state of human knowledge has increased vastly during this time. We have better instruments, better methods by which to know the universe, but the questions remain as they were then. Now, of course, our knowledge of the physical universe was very poor. And so it was thought in Greek times that the earth is, everything around us is made of fire, water, earth, and air, yes. We know that's not quite true, that the basic elements are now quite a few more than just these. Now, there was the question, what holds up the earth? It's a logical question to ask. Because look, this laptop that is in front of you is held up by what? By the table. The table is on the stage. The stage is being held up by the earth, or rather the foundations of this building. But the building is being held up by the earth. So something is holding up the earth, right? Now, what could that be? The biggest load-carrying animal is the elephant. But the elephant has to stand on something. Logical, right? Well, how about a turtle? बड़ा कछुआ जो होता वो बहुत वजन उठा सकता. But something is holding up that turtle. What? Yes, absolutely right. So it's turtles all the way down. But how far down? Well, maybe it's a big turtle at the end of it all. Well, look, we can do a bit better than that now. Well, how did this universe come into being? How did it all start? Well, depending upon where you were born, what religion you believe in, there are different stories. The Jewish and the Christian and the Muslim stories of creation are pretty much identical. That God made the world very, very fast. How fast? Does anyone know? 7 days. And of course, on the seventh day, he got tired. So that's why on Sunday you have a holiday. By the way, I don't think everywhere in the world Sunday is a holiday. I was in Nepal a little while ago, and I found that Sunday is not a holiday, it's a regular day over there. But then, people have different beliefs. So that, I'm not saying this is wrong, that it took 7 days to make the world. No. But you could also believe that it was Brahma who created the world, and then Shiva comes along and he destroys it. But he doesn't destroy it completely, and so Vishnu has a chance to come along and reconstruct the world. And there's a long mythology on this, and I'm not even going to tell you about Zeus and the Greek gods because, they have a existence of their own. Where did they live? Where did they stand? Mount Olympus. Correct. So we're not going to talk about that. We're going to talk about the scientific view of how the world came into being. Well, I use the word world. I should have used the word universe. आइए इधर जगह तो कम है लेकिन actually you can take that chair. ये मुझे इसकी जरूरत नहीं पड़ेगी यार, इसको नीचे कर दो. हाँ ठीक. So okay, so I use the word world in a very loose way. I should have said universe. But then I need to define what the universe is. The universe is, of course, all the matter that we see around us, the stars, the planets, the constellations, the galaxies, and so forth. But it's actually more than that. You must include energy. Energy is there in the universe, and it's not the same as matter, although matter and energy can be converted into each other through E equals mc squared, but energy is still a separate thing. Well, is that all? Answer is no. There is also space-time. Now, this is a very unusual way of putting things across. I mean, space-time, space is there. You've always thought of space as being just, somewhere, some region in space where you can just throw your hand out like this. And time, well, time's there, and nobody thought of space-time as having an independent existence of its own, but now, since Einstein, 1905, and then again in 1916, we know that space-time has an existence of its own. ये बंद करो नहीं तो ये ज्यादा अहम है ना तो नहीं तो इनको नजर नहीं आएगा हाँ अच्छा मैं इधर चला जाता हूँ okay so space time, and we're going to come back to this again because space time is actually something that is not fixed, something that is influenced by the presence of matter, and space time is what makes possible the slowing down of time and, well, perhaps going into the future. I'll tell you why we can't go back into the past, but we can go into the future. All right, so now let's get on with it. The Earth is not, the universe is not made up of fire, water, earth, air. The matter that we see around us is made of atoms. Atoms make molecules, and they make then cells, they make living beings, you and me. So that's on the higher end. But on the lower end, you see over here that inside the atom there is the nucleus. The nucleus was thought of as something that was indivisible, but then we discovered that there are neutrons and protons in it. And this is all very recent. The neutron was discovered just 100 years ago or so. Electrons we knew about for a while because, of course, you can separate them out, and that's what leads to the flow of current. And so electrons we knew about for a while. Protons had to be there to neutralize the electrons. But the neutron was something new and discovered just 100 years ago, as I said. But inside the nucleus, there are these protons and neutrons, and these in turn are made up of still finer particles called quarks. So we're going to talk about quarks in a bit more detail in just a while. You can always ask the question, is there something inside these quarks as well? And the answer is possibly, but maybe very likely, but we haven't discovered that as yet. I suppose most of you must be familiar with the four fundamental forces of nature, but let me quickly review them. So one is gravity. Gravity is the force that exists between any two pieces of matter. So if this is one piece of matter and this is the second piece of matter, they will be attracted towards each other by the force of gravity. The heavier this is, and the heavier this is, the greater will be the force of attraction between them. And of course, the closer they are, the greater the force. So gravity you know about. It's what causes things to fall to the ground. Electricity and magnetism you know about because magnets you've seen, you know about electric current. Electric current is what makes the world go. But there are these two forces. There's the strong interaction and the weak interaction, which are a little less familiar. So let me explain them. See over here, inside the nucleus, there are protons, lots of them sometimes. In something like lead, you would have 82 protons. And protons repel protons, so obviously they want to run away from each other, and if there was not another force, the nucleus would just disintegrate, it would break up. Some force has to exist which is greater than the repulsion between the protons, and that is what is called the strong force. So it's literally strong. ताकतवर कुव्वत. आइए जरा. The weak force is a little more difficult to explain. It's what causes the neutron to break up. If I hold a neutron in my hand after about 8 minutes or so, it'll vanish. Why? Because there's a force acting upon the constituents of the neutron which want to break it up, and that is the weak force. And the weak force is very, very important because that's what causes the energy from the sun to be emitted. And without the weak force, we would have no energy and heat coming from the sun. So that, in a nutshell, are the four forces, and in just one slide, the real constituents of matter. 18 of them. So there are these 6 quarks, 6 leptons. One of the leptons you know, that's called the electron. This is the electron's bigger brother, about 200 times heavier than the electron. And this is about 1900 times heavier than the electrons. These are particles that most people have not heard of. These are called neutrinos. And neutrinos are neutral particles, predicted and then discovered, and now used in a very interesting way to map out what is inside the Earth today. So, because we have a long way to go, and I want to compress billions of years into 30 minutes or so, I'll go fast. But quarks, you know, I really love them, and I've spent a lifetime studying them. Let me tell you what they are. They're the constituents of particles called hadrons. Examples of hadrons are neutrons and protons. There are 3 quarks inside a neutron, 3 quarks inside a proton, different kinds. But the amazing thing about quarks is that they can never be seen in isolation, free of each other. See, you can take an electron and you can make it run along a wire, and that's electric current. But you can't do the same with quarks. But these quarks are there inside the neutron and proton, and you will ask, have you ever seen a quark? And I'll say, in the same sense that I have seen, let's say, this table. How? There's light coming from there, hitting this, bouncing into my eyes. And so there's a source, an object, and then a receiver. So in the case of quarks, we use extremely high energy electrons or photons or some particles which can look at things which are really, really, really small, and then we need receivers which are really, really big. And that's why a typical detector at CERN in Geneva would weigh something like 2,000 tons. So Yes, we have seen quarks. And we are all made up of quarks and electrons. Before I go to my next main topic, let me tell you once more about space-time. See, what I explained to you about gravitation was basically this: there's a piece of matter here, piece of matter here, force between them. Well, you go and measure it, and that's what it is. This was discovered by Newton, but Newton did not know why this happened. The explanation of gravity was given by Einstein, and just 120 years ago, roughly. What Einstein said was that wherever there is a mass like this, it bends space-time around it. Here's another mass, it bends space-time around it. And this is what causes this to be attracted by the other. So, this is going to be important in just a little while. Okay. Now, as I said, we are out to ask the question, how did the universe come into being? And many of you have heard of the Big Bang. I will quickly tell you what it's all about and how we came to this argument that the universe started off with a Big Bang. And then I will give you 3 very strong arguments. You see, in science, we argue. We don't say, you believe this. Because just because some scientist was a very great one, you don't say, ye mera peer hai, main uska murshid hu. No, you don't do that. You say, prove it. Give me evidence. Baith jaiye, baith jaiye. Right. So how did this start? This was about 130 years ago or so. There was this American astronomer, Edwin Hubble, who was looking at the sky with this telescope, and he was involved in making the telescope too. And he was very careful about his observations. Now, he was looking at different portions of the sky. He looked here, there, and then when the telescope turned over with the Earth, he was looking at the other part of the sky. And everywhere he noticed something astonishing. What he saw was that the distant galaxies, what's a galaxy? Anyone? Yeah. A collection of stars. How many stars in a galaxy? Billions. Billions. Yes, my friend. Do you have an opinion on that? Yeah.
My opinion is
100,000? No, actually, it would be more like 10 billion, which would be 100,000. So lots of stars in a galaxy. What he noticed was that these galaxies, not the individual stars, but the galaxies as a whole, are running away from us. And the more important thing, just as important thing, the further they are, the faster they're running away from us. Now, how did he know that they were running away from us? After all, if you look at the stars, do you see them moving? No, of course not. You look at the sky today, you look at it tomorrow, 10 days later, you'll see the same stars. But not only you, but your grandparents and your grandparents' grandparents and 100 people up the line, they would see the same stars there today then as we see them today. And the reason is that the stars are very, very far away, and so you don't notice their motion. You know, if a plane crosses over and is flying low, then you say, shoo, see how fast it's moving? But if it's up in the sky, it's barely moving. You've noticed that. And so these stars are so far away, billions of light years away, that you don't see them moving. But the fact is, they are moving, and this is how Hubble discovered that they were moving, through the Doppler effect. The Doppler effect is what you have learned in school in your physics classes. And what does it say? It says that if something is running towards you, you will see an increase in frequency. If it's going away from you, like an ambulance, the siren will appear to have lower frequency. And that's how you can make out whether something is moving or not. And in fact, the motorway police does it all the time. And you know, if you cross 120 kilometers per hour, you get fined. And it's through the Doppler effect. So that's how he did it. And this is how to represent Hubble's law. So the further away you are, the faster you're moving. That is, a galaxy is moving. Now, this then creates a question in your mind. How is it that Hubble, who was in California, was seeing the whole universe running away from him? Is there something special about Hubble? No. Would we see the same thing here in Islamabad if we put a big telescope on our roof over here? Yeah, of course. Would we see the same thing on the moon, on Mars? Yeah. Would we see the same thing on the other side of the solar system? Yeah. On the other side of the Milky Way, which is 30 million years across. Yes. But how can it be that every place on Earth, every place in the universe is the center of the universe? It seems like a crackpot idea. Well, it's not crackpot. This is a balloon. Think of this as a balloon. And these yellow dots as ants, chuntiyan. And this ant is seeing this ant, and now the balloon is expanding. So this ant thinks that this ant is running away from it, although this ant says, no, I'm not running, I'm fixed. However, it is the space-time, in this case, the space that is expanding, and that is what gives rise to the idea of an expanding space-time. So it's not really a big bang that happened, it is increasing space-time. Okay, let's see how this idea came about. All of you have mobile phone cameras. So imagine that you were to take a video of stuff that is flying out, and you take a long video of things, of the galaxies moving outwards, and then you reverse the video. So now what happens is that everything starts coming together. And if you run the video long enough, everything will come down to one point, and that point is where it all started. Of course, you'll have to run the video for a very long time, roughly 13.7 billion years. So I don't think your video camera will hold that much memory. Huh? This is the time when there were only quarks. And those quarks were free. I told you earlier they were not free. They're not free today, but they were free then. And then they started to form protons and neutrons, like this and this. And the protons and neutrons then started colliding with each other. And remember that the universe is extremely, extremely hot at the very beginning. And whatever was around at that time was moving extremely fast. So they were colliding with enormous speeds, proton hitting proton, creating a very hot object, which then releases a photon, a deuteron. Then the deuterons collide and they create helium and a neutron. And this process continues. So now let me tell you a little bit of history. I've already told you that Hubble saw this 130 years ago. Einstein came up with his theory of general relativity 110 years ago, roughly, 1916. Now, Einstein, when he solved his equation, he didn't know what Hubble had done. Einstein didn't know about Hubble's work, and he thought the universe was static, that things were not moving in it. But he had already laid the foundations of the Big Bang theory. However, it is in 1938. 1939, what happened? What's the big thing that happened in the world? World War II begins. So just a year before that, there was a British astronomer, George Gamow. Gamow was absolutely brilliant, and he was thinking that if the Big Bang is correct, then we should be able to predict how much helium, how much hydrogen, helium, lithium, beryllium, boron is present in the universe today. We should be able to predict their ratios. So he did calculations, and he came up with the prediction. What's a prediction? It's something that you say could be true, and then it is for others to go out and test whether it is true. Gamow predicted that most of the universe today should be made of hydrogen, 75% roughly, about 24% helium, and then all the other elements should be less than 1%. And, well, this was something fantastic to predict, but nobody had the time because the war had just started. After the war ended, astronomers went out and looked for these elements, and they looked into the skies, and they found exactly what Gamow had predicted. By the way, how do you look for elements in the sky when you can't go out over there? I mean, we can only go to the end of our planetary system, and that too only now. But how can you look for elements which are thousands of light years away? Yeah.
Is this related to advanced telescopes, like telescopes that are high tech, or something related to the Doppler effect you mentioned earlier?
Okay, very nice guess. But it's not just telescopes. You see, telescopes will bring distant objects nearer. But how will you know what element is out there?
By looking at their spectrum.
By looking at their spectrum, exactly. So every element has a definite spectrum with it. It's like your fingerprint. You know, these days with biometrics, you can easily find out who is using your computer. And your computer will let it be used only when you fulfill the biometrics. Well, every element has a signature to it. It's got its own biometric. And so that's how we find this out. So two proofs that I've given to you, I won't call them proofs, but two pieces of evidence in favor of the Big Bang. One is the expanding universe. The other is the distribution of elements. And this is now the third. And I won't be able to explain this right now, but in the Q&A, if you ask me, I'll tell you a little bit more. But basically, this was a prediction which was made in the late 1950s, early 1960s, that there should be something left over from the Big Bang, and it should be in the form of microwaves. You know, microwaves you're familiar with in your microwave oven, but these are microwaves that go all over the universe. And they're there in that portion of the sky, they're everywhere. And this was actually discovered in 1965 by two persons working at Bell Labs. And today there are at least 3 satellites in the sky which are further working to refine those observations. And this is called the Cosmic Microwave Background, CMB. The CMB was a prediction of physicists and a discovery by other physicists. So, let's now see what happened immediately after the Big Bang. There was a lot of hydrogen. Even today, the universe is 75% hydrogen. Now, hydrogen was there in little clumps. There's hydrogen here, there's hydrogen here. And within each clump, every part of the clump started to attract every other part. Why? Gravity. Gravity works for gases, it works for solids, it just works for masses. So, the clumps of hydrogen, they started to condense. And as they condensed, their potential energy was converted into heat energy. And that's when the nuclear reaction started, and that's where the first stars were born. Even today, stars are being born. New stars are coming up. If you look today, and you look tomorrow, you won't see them because, our eyes are not sufficiently sharp, but many new stars will have been born. I can't give you an exact number, but many will have been born between today and tomorrow. Okay, so that's how stars are born. But how do stars release their energy? They do it by burning fuel. Your car runs on petrol or CNG, whatever. It has a fuel. When your fuel tank gets empty, the car stops, so you have to go to a petrol station. Okay? There are no petrol stations in the sky. There are no hydrogen stations in the sky. So stars will eventually run out of fuel and then they'll die. And now, look, not only everyone, but everything has to die. Whatever is born must die. Our sun is also going to die, and I hope you don't get too worried by this news. It is it is consuming 600,000 tons of hydrogen every minute. And so with this furious burning of fuel, it's dying. But you don't have to be too worried because it'll take another 4.5 billion years. So that's the good news. Okay, but this star didn't just die, it ran out of fuel and it exploded. This is what is called a supernova. And this is an actual picture which was taken by the Hubble telescope. Hubble telescope was named, of course, after Edwin Hubble. And this has been up in the sky for about 20 years. And it keeps looking all over the galaxies. And whenever there's a sharp pulse of light, it immediately goes and focuses onto that. And this star exploded maybe a few million years ago. But the stuff from it is still going out, and you can see these rings that have been formed. This is a superstar, a supernova that has exploded. The important thing about these supernova is that this is where all the heavy elements were created. There wasn't any at the time of the Big Bang, but the stuff that you and I are made of is phosphorus, nitrogen, oxygen, carbon, etc. That stuff came from supernova. I can talk about the Earth and how the Earth came into being, but there's so little time, we've got to move fast. So now I'm going to come to really what is so important, life. What is life?
Set of collections that differentiate between living and non-living.
Eh?
Set of characteristics that are different between living and non-living.
What is living? जिंदा और मुर्दा में फर्क क्या? What is life? I'm asking you what is life. What? Process of change. Okay, but you know. हाँ पढ़ लीजिए हाँ.
जिंदगी क्या है? अनासर का ज़हूरे तरतीब. मौत क्या है?
इन्हीं अनासर का परेशान होना. बहुत खूब बहुत खूब. बड़ा अच्छा शेर था. लेकिन देखिए हम जानना चाहते हैं कि जिंदगी है क्या, इसकी पहचान क्या है. अनासर की तरतीब तो खैर कार्बन में भी होती है ना, लेकिन क्या खास बात है उस तरतीब की? Anyone? Quick. Yeah.
Anything which is capable of duplicate itself.
Beautiful.
And,
That's exactly the point. Anything that can replicate itself. So life begets life. And that's how things then move onwards. You die, but then you have children. Your children will have children. So unless everybody is wiped out, the human race will propagate. So these are some basic questions. What is life? Well, we need to talk a little bit more about that. I will later. But how does the stuff that was there at the beginning of the earth, how did those elementary particles, those elementary atoms turn into life? And if there's life on earth, could there be life elsewhere in the universe? Of course, we'll talk about the future of life also. So here, you know, every religion, every belief, every society has its own version of how it all started. So the river Nile was thought to be the mother of all life. And of course, for the Egyptians, their life literally depended upon there being water in the Nile. The years that the Nile would be dry, they would starve. And they thought that it was through these eels and worms that the Nile transferred life onto earth. This is also what Aristotle thought. And the English people, they thought life came from the dirty underwear of kings. So other, religions and all that, they all have their version. But what we want is the scientific understanding of the origin of life. So just a little bit more before we come to that, this is a rather technical definition that life is a chemical system that undergoes Darwinian evolution and that takes high quality energy from the environment, and through the process of metabolism, it extracts energy and then throws the garbage away. Now, the assumptions. It needs energy, it needs organic molecules, carbon in particular, because without carbon you cannot form the molecules that are needed for life. DNA is basically carbon, nitrogen, oxygen, phosphorus, and so forth. And you need water, liquid water. Why is water so important? Okay, batao. Why is water so necessary for life?
Because without water, we'd get dehydrated and die. And also another reason we need water is because without water, we won't be flexible enough to move.
Okay. Yes, okay, yeah. Just 1 second before the mic comes to you.
It's the main source of nutrition for most organisms.
No, there's no nutrition in water. You can't get energy out of water. I mean, are you a believer in the water car or what? No. There's no nutrition in water. So what's water good for? जल्दी से बताइए, we need, हाँ इनसे पूछ लीजिए, हाँ.
I don't know, I might be wrong, but it can be a source for hydrogen and oxygen.
Why do you need hydrogen and oxygen? Question is, why do you need water? Okay, quick. Yeah, It makes 70% of your blood. No. Look, there has to be a reason why. Yeah.
Mobility of particles.
Mobility of particles. Okay, so water is an excellent solvent. It'll take away all the gunk, and once the food has been consumed, I mean, what do you do in the morning? What's the first thing that you do? Huh? Okay, good. You have to go to the toilet, right? And get rid of that water and solid particles. But the water you need to get, and why is that water needed? Because your cells need nutrients. Those nutrients are carried by the water into the cell. Once those nutrients have been consumed and they expelled, they have to then go out from there. Okay, so how do we answer this question? How did life occur on Earth? In the beginning, the Earth was like this. There was no oxygen. There was very little oxygen, I'd say. There was lots of sulfur. It was poisonous gases over there. There were earthquakes. There was very, very nasty Earth. And there was lots of lightning. Okay, so there was a chemist by the name of J.B.S. Haldane. And Haldane actually spent a lot of time in Lahore. Haldane came up with this hypothesis that the early atoms and molecules that were present at the beginning could have combined together and created amino acids. And so he thought of an experiment which was finally tested by these two people in 1953, Miller and Urey. And they tested this hypothesis. What is a hypothesis? Anyone? Hypothesis? An idea without physical evidence. And very good. So a hypothesis is a guess, जिसको हम उर्दू में तुक्का कहते हैं. You guess that this is how it might have formed, and the guess was that methane, ammonia, hydrogen, water vapor, all this could have combined together and made amino acids. And then in a way that you don't quite know, those amino acids then form proteins, and from those proteins would come life itself. In fact, the first molecule, you could say the first molecule of life was not the DNA but the RNA. And those of you who have studied biology, molecular biology, know what that is. The first life that came on Earth was these very simple organisms called prokaryotes. And prokaryotes were only capable of one thing, of creating more of their own. So you see, life is about reproduction. And the prokaryotes were reproducing themselves. As they reproduced themselves, somewhere along the line, some mistake happened. And the prokaryotes became, slowly, over millions of years, eukaryotes. Eukaryotes were still very, very elementary, but they had within them a nucleus. That nucleus contained the DNA. And from there, it all started. So, this is what you learn in your evolution class, if you ever take that, or if you are permitted to study evolution. So you had what molecular biologists have discovered is that 3.5 billion years ago, there were the earliest prokaryotes. 1 billion years later, you have these cyanobacteria, which then evolve into all these different categorizations, from which you get the bacteria, the archaea, the protists, the plants, the fungi, the animals meaning fish and reptiles and birds, and much later mammals. And then the mammals are, of course, of thousands of different kinds. So it's like a tree. You know, a tree goes up and then it creates branches. Then from those branches come the branches. From the branches come more branches. And that story takes a long time. It takes 3 billion years to go from prokaryotes to today. But you see how many zeros there are? Yeah, too many. Can you comprehend? Can you, if I took away 2 or 3 or 4 zeros, would you know the difference? Probably not. You know, once there are too many zeros, you start losing perspective. So what I thought I would do is put it in a different way. Suppose the Earth started at midnight, then until 6 in the morning, nothing happened. So the Earth was too hot, there was too much radiation, there were meteors banging into it. The prokaryotes come at 6 in the morning, and they last until 4 p.m., 4 in the afternoon. From 4 in the afternoon to 10 at night, they're the eukaryotes, and then come the multicellular animals, and we humans have been on Earth just for the last 1 minute. So that's how to put this into perspective. And of course, we came through, we didn't come from the apes. This is wrong. But we came from the common tree that led to apes, to Homo sapiens, and the branching, who knows where it'll go, But all these are tied into this tree over here. So it's branching and branching and branching, which has led to this. Now, people in some places, Pakistan included, they say that their sensibilities are offended when this sort of picture comes around. But I'm not offended. हाँ, अगर कोई कहे मुझे कि तुम्हारे दादे का दादा का दादा का दादा पुश्त ऊपर ले जाओ बंदर था, ठीक, व्हाट्स द प्रॉब्लम? साइंस ये कहती है, उससे हम इनकार नहीं कर सकते. या फिर आप इससे भी इनकार करें कि ऑक्सीजन और हाइड्रोजन के मिलाप से पानी बनता है. इनकार आप करें, बेशक जितना भी करना है करें, बट साइंस इज साइंस एंड दिस इज व्हाट द थियरी ऑफ एवोल्यूशन. हाँ, थियरी के नाम से लोग घबराते हैं, लोग कहते हैं ये थियरी का मतलब क्या. अनफॉर्चुनेटली उर्दू हैज़ नो प्रॉपर वर्ड फॉर थियरी. नज़रिया कहते हैं. अरे यार, मेरा नज़रिया तुम्हारा नज़रिया नुक्ता नज़र की बात है. नो, इन साइंस थियरी इज समथिंग सॉलिड. जैसा कि हम कहते हैं कि न्यूटन्स थियरी ऑफ मोशन, थियरी ऑफ ग्रेविटेशन. भाई, इतनी मजबूत चीज है कि 400 साल के बाद उसमें जरा भी तरमीम करने की जरूरत नहीं पड़ी. न एवोल्यूशन में तरमीम करने की जरूरत पड़ेगी, बिकॉज इट्स ऑल सो सॉलिड. एंड येट द साइंस हेटर्स इन दिस कंट्री एंड एल्सवेयर, दे से परे करो, ये खतरनाक है. अरे क्यों खतरनाक है? किस चीज से डरते हो? साइंस से डरते हो तो अपने मोबाइल तोड़ दो. Not to be ashamed. Why? This is how it happened. Lastly, and I hope we'll have a long discussion. People in this world, they fight. मैं काला हूं, तू गोरा है, वो चाइनीज है, वो जापानी है, वो इस नस्ल का है, वो उस नस्ल का है, उसका रंग ये है, उसका कद वो है, उसकी शक्ल और सूरत चाइनीज जैसी है, वो देखो वो उससे बिल्कुल मुख्तलिफ है. सो वी आर ऑल ऑफ डिफरेंट रेसेस. अब बेचारे इधर जो हजारा हैं, they get murdered en masse in Quetta. They have to hide their faces. Otherwise somebody recognizes them and say, मार दो इसको. If we understood that we are from the same genetic tree and that we all came from Africa, 65,000 years ago, there was a mass migration out of Africa in which the human race, Homo sapien, spread not only through Africa, but to Europe, to North America, well, via Greenland, to Australia, and everywhere. It started 65,000 years ago. And, well, now, of course, is the age of globalization. Now you can go in a plane anywhere. But this is so important to understand that it makes nonsense out of all those people who believe in the superior race. These days, in India, we hear this complete nonsense that civilization started in India and radiated outwards, that Sanskrit was created within India, the first human language, and then other human languages came later. What have these people been smoking? But then what have those people been smoking who say we all came from the Arabs? इधर हर एक जो है सैयद बनने की कोशिश में है. Do the genetic testing and you'll find out exactly where your grandfather came from and his grandfather came from, and who are your uncles, your aunts and nieces and whatever. Today, they have genetic testing services. You just provide a spot of your DNA, they'll tell you exactly where you are from. So, I'm nearly done. I can't answer this question. Are we alone? Well, honge, shayad nahi honge. But you see, the point is that where conditions for life exist, whether they be on Earth or outside, life could come into existence there. You can't rule it out. There may be very smart beings in other parts of the universe. They're not there in the solar system. That we know, because we've looked and not found them. But they could be elsewhere. And so now I'm ending over here. And basically what I've talked about, I said that the Big Bang is really, really solid. There's no scientist, there's no cosmologist now. When we say scientist, you could mean anybody. You could mean somebody who studies population genetics. He's a scientist. But I'm talking about cosmologists. Cosmologists are physicists who study the universe, and there's no disagreement among cosmologists about the Big Bang, although initially this was an open question. Now it's not an open question anymore for anyone who's sensible. We don't know as much about the solar system as we know about the universe, but we're learning. And so you see that experiment I showed you which created those amino acids, well, it's been repeated many, many times. What we still don't know is exactly how those amino acids, those building blocks of life, gathered together and made the first living molecules. And, well, where did life come from? Maybe it came from meteorites. We can't rule it out. And the way to test that, you see, everything in science has to be testable. You go catch a meteorite in outer space, and actually they're doing that. There's a Japanese spacecraft which has brought back pieces of asteroids from up there down to Earth, and you test to see if there are biological molecules over there. So far, no, but maybe. And of course, I've emphasized this enough that the evolution of life is a cornerstone of modern science. Not just modern biology, but modern science. You don't want to believe in evolution, please don't, that's your choice. But then don't appeal to science and go to a madrasa instead of going to a university. Right, so now I hope I haven't provoked you too much, but just enough so that you will ask me a lot of questions. Okay, done.
If you make a magnet super strong but not dense enough, will it break like in an explosive way, like explode?
Oh, a star or what?
No, a magnet.
A magnet? No. See, the magnet is always attracting itself. But the reason a star blows up is because it has got very hot gases inside, and the gravity cannot keep it together. The gravity is not strong enough to keep all that hot matter together. That's why it blows up.
Do we know anything about what was before the Big Bang?
I'm not even sure this is a question of science, because in science we look, we ask for data, and we ask for evidence. Now, if space and time did not exist, and we're pointing to the Big Bang as when space and time came into existence. In that case, it is really very hard to say whether this is a scientific question or not. I know that some scientists like to ask this question, but to my mind, it is not a useful question to ask. उससे स्पेस टाइम के होने से पहले क्या चीज थी, क्या पता. So I don't. Answer is science cannot answer your question. Even if scientists try. अच्छा देखिए, साइंटिस्ट और साइंस में फर्क है. A scientist can sometimes be very unscientific in his outside of his field. And so, of course, you have scientists who believe in religion and scientists who don't believe in religion. They can be very good scientists. Like, to give you an example, two people got the Nobel Prize for the same work. One was Abdus Salam, the other was Steven Weinberg. Salam called himself a Muslim. Weinberg was an out-and-out atheist. But in their scientific work, they were the same. But in terms of what they believed outside of science, and I think your question is outside of science, they can differ.
Okay. I'd like to, yes, add to the question. The gentleman asked, are there any scientists who are working on this question, that what came before the Big Bang? And my own question after that would be, like, how far away are we technologically to create a prokaryote?
What came before the Big Bang, I'll tell you, is not a wholly unscientific question. I'll tell you why. Okay, since आप दोनों ने पूछा ना. So, in quantum mechanics, there is uncertainty. And that uncertainty results in particles not having a definite position and a definite speed at the same time. But it is even more, it's even more complicated than that. Space-time also is governed by the uncertainty principle, which means that as quantum gravity becomes more and more important, which it does towards the Big Bang, then the notion of time becomes fuzzy. And so the fuzziness of time, this is in the area of physics which is not properly understood. It's called superstring theory, quantum gravity, and so that's why there are scientists who are looking at this. How long will it take to develop prokaryotes? We know that it took 1 billion years, but maybe it can be done faster in different circumstances on some exoplanet. By the way, you know about exoplanets. Exoplanets are planets that go around other stars of the solar, or other stars in this galaxy and outside, and there the conditions may be better than on Earth, or worse, who knows?
So not in the lab?
No. This is not a lab scale thing. Yeah.
I have two questions, actually. Is there an answer for where quarks came from? And how do we know that quarks exist?
Okay, so what we definitely know is the expanding universe, which when extrapolated backwards makes things extremely, extremely hot. We know from our experiments that neutrons and protons exist, and within those neutrons and protons, as I tried to explain, we have seen quarks, but those quarks are bound inside neutrons and protons and other hadrons. So at the physics that we understand is valid until the first millionth of a second of the universe, but not valid for the first billionth of a second. So, where did the quarks come from? Probably from vibrations of what are called superstrings. And superstrings gets us into the area where our physics is not sufficiently advanced, to answer your question.
Yes, sir. Yeah. Thank you for the insightful talk. So, in a similar vein to what these people asked, one question that I struggled a lot with as a teenager was like, why do I exist? You know, so something that maybe if it's in the realm of science, could science answer why or maybe how is there something rather than nothing? You know, ये भी तो सकता था कि universe ना होती कुछ भी नहीं होता. तो ऐसा क्यों है कि universe है? Is there a scientific answer to this?
No, there's no answer. There's no reason for me to exist. I happen to be. Did I ask somebody? Did I ask my parents to produce me? No. I just बस है. What is my purpose? अब यहाँ तो ये बात आती है ना, कुछ लोग कहते हैं उनको जन्नत जाना है, कुछ कहते हैं कि हमें एक आसूदगी खुशी की ज़िंदगी गुजारनी है, कुछ कहते हैं कि हम निर्वाणा की उम्मीद करते हैं. तो यहाँ नुक्ता नज़र की बात आती है. So if you ask me from a scientific point of view, is there a purpose of life? I will say no. There is no purpose to life that science knows about.
My opinion on what is before the Big Bang is, I think God created the Big Bang, and I believe the multiverse theory. There are many other universes other than this universe. Yeah.
Okay, that's a matter of belief, and you're perfectly entitled to that. My only problem with multiverses is that how will I know that a multiverse, that some other universe exists? I have no means to communicate with that. And so just as God could exist, a multiverse could exist. But you see, I'm a very simple person. I need proof. And so until I have evidence, I'm not going to believe in anything. I mean, otherwise, यार तुमको बचपन में भौबिल्ले से डराया गया था कि नहीं? मैं बहुत डरता था. वो रात को आता था और जो शैतान बच्चे हैं उनको उठा के ले जाता. तो that's a fairy story. वो डराने के लिए होता. I've never seen a bahubilla. That's the problem. Or tooth fairy. You all know what tooth fairies are. Well, बचपन में हम इन चीज़ों को मान सकते हैं, लेकिन बड़े होते हैं ना तो we start asking for evidence. बताओ सबूत कहाँ है? I'm not saying multiverses don't exist. In fact, it was physicists who said that multiverses should exist because there is a problem with interpreting quantum mechanics, and some very smart people have made the claim for multiverses. So I'm not saying they're wrong.
Science tells us that entropy always increases in the system of nature, but at the same time we are seeing that life has evolved in the most amazing forms, organized forms. So isn't it ironic?
देखिए, ironic तो ये is a very loaded term. But is it possible if you ask? And I'll say certainly it is possible, because take this room, okay? Now, a portion of the gas in that part of the room could come over here to this portion of the room. And so the entropy in that part of the room will decrease. The entropy over here will increase. However, the sum of the two entropies will remain the same. So yes, you are right that complex forms of life are being constantly formed. That results in a decrease in entropy, but that increase in entropy has occurred somewhere else. The total entropy remains constant.
isn't a question, but I just want to add on to what he said. There are a lot of galaxies and lots of universes in which we don't exist. There are lots of places where there is nothing rather than something.
There is certainly, there are parts of the universe where you can go for millions of miles, millions of kilometers without encountering any matter at all. Yes, that is absolutely true, but the universe is very big. You come to this part of the universe, you come into this black hole, and you find that there's lots of life over here, you included. So the emptiness of the universe shouldn't bother you. Is that what bothers you? Yes.
This is pretty general, but why do you think that there are no Muslim philosophers nowadays?
Well, there never were. Name me one Muslim philosopher. Name? किसने कहा? और आप जानते हैं कि फाराबी को कितनी गालियां पड़ी अल्लामा इकबाल की तरफ से भी.
That is the reason why we don't have philosophers, because anybody who advances a theory which is not in consonant with the general opinion of the Maulanas, well, they don't survive.
जी बिल्कुल बिल्कुल. The point is that philosophy requires you to have an open mind. और अल्लामा इकबाल ने कहा कि दिमाग के दरीचे अगर खोले जाएं तो उसके अंदर कुफर घुसेगा. उनका एक शेर है, आज़ादी अफकार है इब्लीस की ईजाद. उसका एक मिसरा है, आप मुझसे ज़्यादा जानते हैं इस मामले में. इब्न सीना को भी बहुत लताड़ा उन्होंने कि ये यूनान की पैरवी करते हैं. इब्न रुश्द तो इब्न रुश्द के नाम से आज 90% उलेमा या 99% उलेमा घबराते हैं, धुतकारते हैं.
So you just talked a little bit about the interpretations of quantum mechanics. So I want to ask you that do you believe that the many worlds interpretation has the potential to solve the measurement problem?
It was created for solving the measurement problem and the collapse of the wave function. Yeah. So the point is that in quantum mechanics, when you make a measurement, the mixture of states collapses into one single state. Yeah. And that violates the Schrödinger equation.
Yes.
So to get around that, this theory was created in the 1950s, that whenever you make a measurement, a new universe comes into existence. Yes. And so there are uncountably many universes presently existing. So as I said, look, many smart people believe in this, but it's a very technical and refined question that those who know quantum mechanics alone can appreciate. Will this ever be experimentally testable? You know, I always come back to this. That which you cannot test experimentally, to me, is not science. So if this can be tested, I'll be very happy. But I don't know how. And unless they give us a means, a procedure by which we can test for multiverses, I'll say, nice thought, but come back later once you give me a method.
Okay. Thank you.
I want to ask, 13.7 billion years is an age of the universe that
13.7.
Yeah, 13.7 billion is an age of the universe that we've predicted, because that's how far the Hubble telescope has shown us. If humans were to develop something stronger than that, would the age of the universe be changing, or are there other factors that are justifying this age?
Okay, so when Hubble made his first observations, it was around 14 billion. And now, because of much better observations, this has changed by a little bit. So it's 0.3 out of 14, which is not a big change. I think that in the next few years, in next few decades, there'll be better telescopes that can look out further, and so we'll get some small improvement on this. But there will not be a fundamental change of paradigm. We will not be saying, oh, the Big Bang is all wrong, because there's so much evidence behind it that this is just as solid as Newton's laws of motion now. I mean, we don't start suspecting Newton's law of motion because there are millions and millions of confirmations. Anytime you send a spacecraft to Mars or the moon, or put a satellite in orbit, you're using Newton's laws. And so I think the Big Bang is very solid.
शुक्रिया सर,
जनाब।
वेरी वेरी इंफॉर्मेटिव और बहुत ज़्यादा सीखा है आज भी। एक आपका जो स्टेटमेंट है कि जी पर्पस ऑफ लाइफ पे, तो जब हम इवन हाई एनर्जी पार्टिकल फिजिक्स को देखते हैं, बहुत सारे एलिमेंट्स जो एमिट कर रहे हैं पार्टिकल्स, हम कहते हैं कि वो एक स्टेट ऑफ स्टेबिलिटी को अचीव करना चाहते हैं. Positron, neutrinos, all this, what they eject from the neutrons, magic numbers, physics theoreticians उन्हें कहते हैं. तो elements तक जो है they are trying to achieve in million of years some state of stability. How a life and a purposeful person like us consciously can be without any purpose. इस पे अगर फिजिक्स का सवाल है तो काइंडली
जी स्टेबिलिटी की बात बिल्कुल आपकी मुनासिब है. देखिए, अगर आप कोई यहाँ पर एक इस शक्ल की प्याली आप लें, इधर आप एक गेंद रखें, तो ये गेंद या ये जो भंटा है या जो भी गोली है, गोली इधर आखिर ठहर जाएगी, आगे पीछे जाएगी, आखिर इधर ही आके ठहरेगी. गोया कि हर शय आखिर सुकून चाहती है ना. हाँ, तो उसको सुकून यहाँ पे मिला, इधर आकर ठहर कर. तो ये तो स्टेबिलिटी की बात हुई, लेकिन इसका कोई मकसद है, मकसद हयात है? एटम का कोई मकसद हयात नहीं हो सकता. बिल्ली का ये है कि वो अपनी नस्ल आगे बढ़ाए, खाना खाए, नस्ल आगे बढ़ाए. ठीक, मुनासिब. जानवरों का भी यही है. अब इंसान ने ये सवाल किया अपने आप से कि हम क्यों हैं यहाँ पर. तो अब उसके मुख्तलिफ जवाबात मिल सकते हैं, और वो मैंने इनके सामने रखा. तो जिस मुआशरे में आप पैदा होते हैं, आपको जो बताया जाता है वो अक्सर लोग मन और अन कबूल करते हैं.
शुक्रिया जनाब. बहुत दूसरा सवाल छोटा सा, ये पिछली सदी के पहले हाफ में बहुत ज़्यादा आइंस्टाइन और दूसरे जो कंटेम्प्रेरी साइंटिस्ट थे, उनमें डुअलिटी और ये अनसर्टेनिटी, ख़ास तौर पे क्वांटम मैकेनिक्स के जो लेटर पार्ट्स हैं, जो हाई एनर्जी पार्टिकल फिजिक्स है, इसके सब एटॉमिक पार्टिकल्स, ये रही कि हाउ वी डिस्क्राइब दैम. और फिर बहुत सारे लैब्स एक्सपेरिमेंट और फिर बहुत सारे झगड़ों के बाद यही तय हुआ कि दिस डिपेंड्स हाउ वी लुक एट इट इन द एनवायरनमेंट.
बिल्कुल सही कहा.
तो ये आप एक्सटेंड कर सकते हैं जनरली कि whatever we are looking at it greatly depends how I look at it.
जी बिल्कुल बिल्कुल. आप देखिए, इलेक्ट्रॉन को हम एक जर्रा समझ सकते हैं या उसे एक लहर मान सकते हैं. दोनों बातें दुरुस्त हैं, लेकिन कौन सा नुक्ता नज़र ज़्यादा मुफीद है, फ़ायदेमंद है, वो इस पर मुनहसर है कि आप तजर्बा क्या कर रहे हैं, आप उसको किस हाल में रखते हैं, और फिर जो भी पेशन गोई होगी ना, वो एक ही होगी. हाँ, आप उसको ये समझें या वो समझें, लेकिन जो आपका इंस्ट्रूमेंट दिखाएगा आखिरकार, वो ऐन वही होगा इस थ्योरी के हिसाब से, या इस थ्योरी नहीं कहना चाहिए, इस नुक्ते नज़र के हिसाब से या उसने, तो नुक्ते नज़र से फ़र्क नहीं पड़ता, इसको ड्यूअलिटी कहते हैं.
Can I ask that why there were hostile conditions from the?
Oh, हाँ.
Can I ask that why there were hostile conditions before the beginning of the Earth, the universe, basically?
There was from the sun a lot of ultraviolet radiation, and ultraviolet radiation is extremely dangerous. If it wasn't for the atmosphere, we would all be we would not be able to live. Plus, there was very little oxygen, and there was also very little water. Now, this is actually a very interesting question. Was water there at the beginning of the Earth, or did it come from outer space? And it is now pretty much believed, so I'm not saying confirmed, that most of the water came from outer space. So there wasn't enough water, there wasn't enough oxygen. You know how the oxygen came about. It came about because there were plants. The plants produced that oxygen, and in fact, when your children's children go to Mars, they will be breathing oxygen which is produced by plants planted on the Martian surface. So in the beginning, the conditions were very hostile.
How is there any scientific explanation or any like reason as to how we got rid of the sulfur, the poisonous gas, and the lightning that was present initially before the Big Bang and all that?
So it wasn't just the sulfur dioxide and other sulfur form, but it was lack of oxygen. And as I was just explaining, the oxygen came from plants, and the lightning. Well, there's lightning today as well, but there was the atmosphere today protects us from a lot of radiation, and the amount of heat that there was earlier on, the planet was very hot initially, you know. It was all molten, and then it started cooling, and that's how the outer crust formed. It remained extremely hot for a billion years. But then the steady cooling that happened then made life possible.
How did it start cooling?
Every hot object cools. It radiates off into space. It radiates heat off. You know, if you have an electric iron, you put your hand close to it, not too close, you'll feel the heat coming off from it, right? Or you take a rod heater, you feel the heat coming off. That's radiation. In fact, there was the big question, why is the Earth so hot today? It should have cooled off billions of years earlier. And today we know the answer, because inside the Earth there's radioactive material that's giving off heat.
So you were talking about how hydrogen and oxygen basically makes amino acids, which then, yeah.
No, not hydrogen. There's also methane, ammonia. You need carbon, hydrogen, nitrogen, oxygen.
Yeah, okay. But at the same time, you were saying that the oxygen was pretty less at that time. And the oxygen now comes from plants. So how did plants really form then?
That's the whole idea behind evolution. So you have the early prokaryotes which can live in very hard circumstances. In fact, bacteria continue to live even inside nuclear power plants. Now, you know, a nuclear power plant, lots of them across the world, they are very hostile to life. There's radiation, there's heat. But in spite of that, some forms of life are so resilient that they can survive that environment. So in early days, these prokaryotes, they lived in all that sulfur, in the poisonous gases, in the heat, and they could survive and then evolve further. They could evolve further because it was then later on not so hot.
Do particles, for example, tachyons that can travel faster than light exist?
No. The tachyon is an imagined particle. In fact, it's a condition that we use in particle physics that there should be no tachyonic solutions of our equations. So tachyons, you can create any kind of name and put an ON in front of it, but that doesn't make it real. The point is that nothing can travel faster than the speed of, no information can travel faster than the speed of light. And any theory that is proposed by someone has to pass this test. If it predicts the existence of a tachyon, you say, why don't you go home and look at your equations again?
If we can theoretically...
Where are you?
If we can theoretically go in future, why can't in past? And my second question is, in several religious school of thoughts, the universe is made for us. Is there any scientific explanation? Are we made for the universe, or universe is made for us?
Okay, good. Why can't we go? Well, look, we can go into the future. So that's not a problem, actually. And this was more than 1905, Einstein's theory of relativity. The famous question, two twins are born on Earth. One stays on Earth, the other goes to a distant planet, travels very, very fast, and then comes back. The twin who is at home on Earth, he has aged, whereas the other one is still young. Has this been tested? Answer is yes. But not with twins, with particles. With, there are particles that live for only a short time. And if you move them around fast enough, then they will live much longer, maybe 1,000 times longer than they're supposed to. So in that sense, this has been tested. And the second part of your question was, are we? So there's a very famous physicist by the name of David Merman who wrote a very provocative paper. It was called, "Does the moon really exist if we don't look at it?" Meaning that it is the observer who gives rise to reality. I don't want to get into that, but if somebody is really interested in quantum mechanics, I can forward that paper. Was the universe made for us? I don't think so. I think we just happen to be there. It's quite accidental that my father married my mother. He could have married someone else. I wouldn't be here. You wouldn't be here either. So we are here by accident. And the universe would still be there if I wasn't there, or you weren't there, or my cat or dog were not there. Do you think the stars care for what we are, or what we are thinking, or what we do? No. The universe will keep doing whatever it is doing.
Can the galaxies replicate? I mean, can the galaxies be similar? Is there a galaxy that is similar to the Milky Way and contains the same planets?
Highly, highly unlikely. In fact, I'd say unlikely to the point of being impossible. In fact, exact duplication is so utterly rare. There are no two people on Earth who are the same. Even twins are not the same. If you look at, so the famous example is that of snowflakes. No two snowflakes are the same. And now you are asking for two galaxies to be the same, of which the chance is zero.
Okay, thank you.
इधर भी देना.
I won't really call it a question. You see, the whole question on board is we're questioning the existence of the universe here. So, in all totality, it is so the perfection in the universe. We cannot. There has to be. It's okay. How should I put it? We're living in denial if we cannot accept that there has to be a creator. There has to be a creator. It's too perfect. Let's just take the golden ratio 1.618. How can you not come to terms that there is a creator? This is not all coincidental.
Oh, you say.
And then you questioned about observing the moon. Just because we haven't seen God doesn't mean that he does not exist. That's my observation and my take on this.
That is perfectly okay. That's a point of view. It is, yeah. It's perfectly fine. But I do disagree with you on one thing. You said the world is perfect. I see it as very imperfect. I mean, what kind of a world is this in which you see the slaughter in Gaza day in, day out, and you see, well, that's the human side. It is extremely imperfect over there. Why are they mosquitoes? They serve no purpose so far as I can see. And these dangerous and more dangerous kinds of mosquitoes, who is bringing order into this universe? I am sorry, I don't see perfection at all. I see kids born with birth defects, polio. Was it their fault? What perfection is this? That you create a child who is crippled from birth? Or someone who's ugly or stupid and has no chance of survival in the world? That's not a perfect world at all. But maybe you meant something else?
I think so. I think there has to be a creator.
Oh yeah, there's no difference. I don't deny that. I am perfectly happy with you. Yeah, as I said, that's something outside of science, whether there's a creator or not a creator. And people have discussed this for 10,000 years and not found a resolution. Because in science, our instruments engage with what's out there, not what you think might be out there. Yeah.
So there was a recent study that suggested that the existence of dark matter implies the existence of a reverse universe starting from the Big Bang. Do you have something to say about this?
Yeah, so there are, when I said that the Big Bang is very solid, that doesn't mean that there are no remaining questions. One big question is, why are there so many black holes in the universe, and why are they so big? In fact, the supermassive black holes. That question is related to the dark matter question. And it could be that dark matter was created in huge amounts at the beginning, just some microseconds after the Big Bang. And it is those black holes, it is that dark matter which eventually became black holes. But dark matter we have yet to see in our labs. See, this is one thing. We say we believe in dark matter, but we are not. But we put this not at the same plane as does God exist or not. Why? We don't see dark matter, and yet we believe it is there. In fact, if you go to Google and ask for the dark matter distribution in the universe, it will give you a complete mapping, and this is based upon what we have learned from satellites, not through light, but through how galaxies cluster. And so there are observable effects over there. There's no speculation.
So, my question was that so we see the way when we're studying science that it fits like almost perfectly with mathematics, and you can apply mathematics to science in a really like special and perfect way. So, why do you think that is? And do you think that like mathematics is something that humans created or discovered?
Lovely question. Again, I don't know the answer to that, but so we come now to matters of belief, and I think we created mathematics rather than discovered it. Because look, 2 apples plus 2 apples is 4 apples. That's discovery. If I take 3 apples away, that's 4 minus 1, which is equal to 4 minus 3, which is equal to 1. That's discovery. Yeah, but then when I ask the question, what is 3 minus 2? What is the number 3? What is the number 2? I'm not talking of apples or oranges. There it is my mind which created the concept of 3. So numbers are a creation of the human mind. Yeah, we had experience with apples and oranges, but we extracted from that the concept, the imagined thing which we call numbers. Ji.
Okay, so I want to approach the question of purpose from another dimension. So I've been reading Dostoevsky lately, and what he holds against the staunch rationalists or people of science is that he says that they see the very flexible humanness, the element of humanness in humanity, from a very rigid black and white lens. So how you just said that there's absolutely no purpose to life, but the very reason, the very fact that we are having this conversation in 2024 regarding whether there's a purpose
25.
or not, 2025, the very fact that from Muhammad to Dostoevsky, from Camus to Nietzsche, people sat down, people thought, people either negated or supported this notion. This passion for discovering some source of meaning to life, isn't this a hint towards some underlying passion that we are yet to discover? But how it is so blatantly and categorically negated by the men of science, is it really a matter of science or the prejudice that they hold against the religious people? Because historically, religious people have been very atrocious towards them. So is it an approach of science to negate the possibility of passion, or is it just the prejudice of the scientific people?
That was very well put. Thank you for that. I've always enjoyed Dostoevsky, but I didn't read him that closely from this point of view. Why do you say that scientists negate the idea of God? They don't. They say God doesn't matter to us. He could be there, could not be there. There could be jinns, there could not be jinns. Who knows? It's what we do with matters of prediction. And in this matter, all religions, every single religion has had nothing useful to say about science. Not one little bit. Look, you guys have heard from the very beginning that this is in this holy book and that is in that holy book. Or we foresaw the Big Bang 2,000 years ago, 1,400 years ago. Sab theek hai, okay. But give me a prediction, give me a machine, give me a theory that's testable. And I say zilch, zero. So in that sense, we scientists are very happy with God. We say one God, or as the Hindus say, 5,000 gods, all okay with us. No problem at all. You believe your thing, they believe their thing, no problem. But we're not going to burn the midnight oil worrying about how to get God into our equations.
Okay. My question is that all this talk about meaning and everything, it begs the question that when in the point of history did we become sentient enough to question the meaning of life?
I think this is wonderful. Look, do you know of any animal that has a religion? No. They can't have a religion because they're not sufficiently aware of themselves. They're not sufficiently capable of introspection, of looking into themselves. So it is a form of intelligence. Religion is a form of intelligence. You can only have a religion when you are sufficiently evolved as a species. When did we evolve? I mean, the first god that I have read about was the river Nile. And the river Nile, because it gave life to everybody, was worshipped by the Egyptians. And then around that grew up priesthood, because the priest could say that we know when the river Nile is going to be happy, when the god Nile god is going to be happy. And in order to make the Nile god happy, you have to give us hadiyah. And so that's how priesthood was established in the Nile religion. And then came other religions with their own interpretations of the universe, none of which I'm saying is wrong. No. Everything could be right, except I don't care. Why should I care?
Sir, here.
Huh.
So are the findings of James Webb Telescope in alignment with this Big Bang theory?
Oh yes. It's a refinement of that. So the James Webb Telescope can look in the infrared region of the sky, which is actually very difficult because you have to keep your telescope cold and away from the sun, and it has to be very, very cold in order to be able to observe the infrared. But yes, the James Webb it's like a more powerful telescope and nothing more.
And secondly, we can't go into the past, but we can look into the past when we are looking the sky, night sky. All the stars we see, they are in fact in the past. That's what we can say at least.
Oh, absolutely. And we are looking into the past. You know, the sun, if it was to disappear, we would not even know that it has gone. We would know 8 minutes later, because that's the time that light takes and gravity takes to come to us. So if the sun was to disappear at this moment, exactly at this moment, next 8 minutes we're all fine. After that, not.
Thank you.
Okay, right. Last 3 questions, maybe.
Does science explains consciousness? Because it's a very intriguing concept associated with life, because life could exist without consciousness.
I think maybe a very primitive form of life could exist without consciousness. So prokaryotes could exist, but once you start talking about, let's say, fish, are fish conscious? I think they are, because they go from cold water to warm water, or warm water to cold water. They look for sources of food. They know that they'll be able to find still smaller fish to eat. So they have to have some form of situational consciousness. You and I are conscious for multiple reasons. One is that we have so many sensors on us. So I know that this over here is hard. My fingers tell me that. I can see so many different colors. I can hear so many different sounds, etc. Think of creating a robot that's conscious. The first thing that you will give it is situational consciousness. Then, once you have sufficient number of sensors, then you will look around for a mind that is trained on those sensors. So here comes ChatGPT and large language models, artificial intelligence. Would you say that ChatGPT is insensitive to your feelings? Have you tried using it? Is it insensitive to your feelings? Okay, so on the other hand, you can put in certain sensitivities into large language models. So for example, go home and try this. Ask ChatGPT if Israel is committing genocide in Gaza. I actually had an argument with a bot on this. A televised, full argument in Karachi, Beacon House people, they invited me. And the bot refused to answer this question. Then I said, can you tell me if Russia is committing genocide in Ukraine? And of course it said, and then it rolled out the facts. So there is sensitivity over there. It depends upon how it's been programmed. So you see, consciousness. So that bot is conscious, but not sensitive enough like you. Your degree of sensitivity is much higher than what any bot or LLM can achieve presently. It's an open question whether we can create consciousness through these means or not.
सर मेरा क्वेश्चन आपसे ये है कि लाइक आपने जो एग्जांपल दिए ना सामने, मैं काफ़ी देर से उस पर सोच रहा था कि लाइक एट द एंड हर चीज़ अपनी स्कूल ही जाती है, तो ये सवाल ही क्यों बनता है कि खुदा है या साइंस है?
भाई ये तो हमें देन, ये फितरत की देन है ना कि हम मुतजस्सिस हैं, हम वजूहात तलाश करते हैं, हम जानना चाहते हैं कि आसमान नीला क्यों है, परिंदे कैसे उड़ सकते हैं, हज़ारों इस तरह के सवाल हैं. तो ये वो चीज़ है जो हमें शुरू दिन से हमारे अंदर होती है. ये कोई, मैं नहीं कहूँगा कि फितरत का कानून है, ये तो है ना कि ये सुकून चाहेगा, और इसकी वजह हम यूं बयान करते हैं कि इधर पहुंचकर इसकी पोटेंशियल एनर्जी सबसे कम होती है. लेकिन क्यों एक शख्स इतना मुतजस्सिस और ज़हीन है और दूसरा नहीं है, इसकी वजह तो मैं नहीं बता सकता. हाँ, सुकून तो हो जाता है ना, आखिर तो सुकून ही सुकून है. हाँ, जब मुकम्मल सुकून हो, जब आपकी कोई ख्वाहिश बाकी ना रहे, कोई तजस्सुस ना रहे, कोई उम्मीद ना रहे, कोई मायूसी ना रहे, फिर तो आप मर गए ना. मौत उसी को कहते हैं. अनासिर का परेशान होना तो बाद में आता ना, फिर तो उसके बाद वो बिखरने लगते हैं.
Briefly on the 18 different types of particles, I saw the Higgs bosons. Could you just quickly elaborate on those?
There are two fundamental types of particles, fermions and bosons, and they are physically the difference between one and the other is that the fermions spin, the bosons don't, or if they do spin, this is in a different way. The social properties of these particles are entirely different. Bosons love each other, fermions hate each other. But more we can talk about later. By the way, the person who invented bosons, Satyanath Bose, he was, there'll be a program on him at the black hole in the next 2 weeks. And he got, it's a very beautiful story of his correspondence with Einstein. And his last remaining student is still alive, and we'll be talking to him here. हाँ, अच्छा, बस वो एक आखिरी उधर से, हाँ. Make it a nice short one.
I have a theory of what was before the Big Bang. So basically, you know how some the universe is going to decay in probably 10 power by a lot of years. So apparently I have this theory that when the universe will decay enough that there's literally nothing in it. Just when that happens, not a billionth of a second later or earlier,
Okay.
it will make another big bang.
Okay, I get you, that there will be a big bang after this big bang and it'll keep going on. All right, well, let's hope that you develop on this. But do it after reading Einstein's equations, okay? Okay.